The arbitrage-free valuation model. In this reading, we'll talk about the meaning of arbitrage-free valuation, especially in the context of bond valuation. A central concept when we talk about arbitrage-free valuation is the binomial interest rate tree. We will learn how to create the interest rate tree, the binomial interest rate tree. We will look at how this tree is calibrated against market reference rates. And then we will use this model to value option-free bonds. Then we will move on to pathwise valuation because they are bonds that have options or bonds with embedded options where the value depends on the path of interest rates. So for this, we need a technique called pathwise valuation, and related to that is the Monte Carlo method. The final segment of this reading is about term structure models. So these are models that predict future interest rates. First, a simple definition of arbitrage. Arbitrage refers to a situation where we earn riskless profits without any net investment of money. Now, if there is an arbitrage opportunity in a well-functioning market, the prices will adjust very quickly until there are no arbitrage opportunities. So clearly, if a particular asset A is overpriced, then traders will sell this very quickly and the price will come down to the fair price. Arbitrage-free valuation refers to an approach to security valuation that determines security values that are consistent with the absence of arbitrage opportunities. This is a mouthful, but the definition has been taken from the curriculum and I think it's very appropriate. So in other words, our approach or our model is such that it comes up with prices that do not allow us to make arbitrage profits. The value of any financial asset is equal to the present value of its expected future cash flows. You have studied this in detail at level 1 and you have also seen this at level 2 in various topics. The link between this and arbitrage is that when an asset is valued using this method, where we look at expected future cash flows and then come up with the present value of those cash flows, then the number that we get or the value that we calculate is an arbitrage-free value. A related concept is the law of one price. Arbitrage opportunities arise as a result of violations of the law of one price. The law of one price states that two goods that are perfect substitutes must sell for the same price in the absence of transaction costs. We will now look at a more precise definition of arbitrage, and we will consider some scenarios where the law of one price is violated and this results in arbitrage opportunities. First, the more precise definition. An arbitrage opportunity is a transaction that involves no cash outlay yet results in a riskless profit. Now let's look at the first scenario. Asset A is a risk-free coupon bond that pays off $1 and is priced today at this number. Asset B is a portfolio of 105 units of asset A that pays off 105 1 year from today and is priced today at 95. This information is depicted here. Notice that we do have an arbitrage opportunity here. This sort of arbitrage opportunity is called value additivity, and it is because the portfolio, which is B, does not equal the sum of the parts. So how can a trader take advantage? Say at time t equal to 0, the trader sells 105 units of asset A and he will sell here for $100. So he makes $100 by selling 105 units of A, and then he buys asset B for 95. Net amount pocketed by the trader is plus 5. Then at t equal to 1, notice that both 105 units of A and bundle B produce the same cash flow. So if he had shorted A and needs to deliver at t equal to 1, how much does he need to deliver? He needs to deliver $1 times 105, which is 105. So this is how much he needs to pay at the end. And from B, he gets plus 105. So the net amount that he owes at the end is 0. So notice that without making any investment of his own, so no cash outlay, yet he earned a profit of 5. So in this case, the law of one price is being violated and there is an arbitrage profit. A trader would keep doing this until prices adjust and the arbitrage opportunity goes away. Now consider another type of arbitrage opportunity. Say we have two assets C and D which are both risk-free, and the pricing is as shown here. C is for 100 today and the payoff in 1 year is 105. So this represents a 5% return. D is priced at 200, payoff 1 year later is 220, and here the return is 10%. When we have two similar assets with different returns, then the type of opportunity or the type of arbitrage opportunity that arises is called dominance. And it is fairly obvious how we make money here. Let's say that we sell 2 units of C at a price of 200. So this is at time t equal to 0. Since we are selling C, we get $200, and those $200 are used to buy asset D. The net cash flow at time t equal to 0 is 0. Then at t equal to 1, notice what happens. Here, the 1 unit of D at t equal to 1 is going to give us 220, and since we had sold or shorted 2 units of asset C, the amount that needs to be delivered at t equal to 1 is 210. The net gain is 10. And here again, there was no cash outlay at t equal to 0, but we still have a profit. Now try example 1. So here is what needs to happen. We have bond A and we are told that this is a 3% coupon bond, 10-year annual pay, and we are told that the yield is 2.5%. The price is given. We simply need to come up with the price given these numbers, and if the price is equal to 104.376, then there is no arbitrage opportunity, and if the numbers are different, then there is an arbitrage opportunity. The curriculum uses the long-winded method of showing all the cash flows and then discounting each cash flow and then showing that the number actually equals 104.376. I will remind you that for something like this, you need to use the calculator. If the bond is a 3% coupon bond, it's 10-year annual pay, so N is equal to 10. The payment is equal to 3, so on $100 par value, it's an annual pay bond, so the yield is 3. The interest rate is equal to 2.5%, that's the yield. And what we need to also put in is the future value, which is 100, and you compute the present value, you will get this answer. So with bond A, there is no arbitrage opportunity. With bond B, you follow the same procedure and you will actually get a price which is different from this number, and that means that there is an arbitrage opportunity. When you do the calculations, the price that you should come up with is 98.311. So what are the implications of arbitrage-free valuation for fixed income securities? These are some fairly obvious points, but they are important. Using the arbitrage-free approach, any fixed income security should be thought of as a package or portfolio of zero coupon bonds. So in the bonds that we just talked about, if they were payments for 10 years, so 1, 2, 3,